Hey guys, so in this video we are going over the study guide or the test review for a test tomorrow for Unit 4B. So for number 1, we are given sine of negative pi. So if you want to, you can kind of sketch out what that angle looks like. So if we had our y-axis, our x-axis, and our circle, our unit circle, your negative pi angle would be going around our circle all the way to this line. So that would be your negative pi angle. So then we're looking at our unit circle. And we're looking for the y value on that line. So where that pi and 180 degrees is, that y value is 0. So your y value is 0. And again, you're looking at the y value because it's sine. So your answer is 0. Now let's look at 210. If you want to sketch it, you can. On your unit circle, you're looking for 210, which will be somewhere over here. So it's going to be the first line after our 180. So that's our 210. If you look back at your unit circle, you're looking for tangent of that line. So you have an ordered pair of negative square root of 3 over 2 and negative 12, or negative 1/2 as your ordered pair. So for tangent is a little bit different. It is sine over cosine, which is the same thing as our y over x. So our y value was negative 1/2. And then we've got to divide by our x value, which was negative square root of 3 over 2. Well, we have to keep the first fraction, change the multiplication to, or change the division to multiplication, and change our second fraction by flipping it. So we're keeping our first fraction, changing to multiplication, and flipping our second fraction. So if we multiply straight across, we get negative times a negative is a positive 2. And then in the denominator, we have 2 times the square root of 3. So we can simplify by canceling out our 2's. We end up with 1 over the square root of 3. We cannot stop there. We have to multiply or rationalize. So we multiply by the square root of 3 in the numerator and the denominator. Multiplying straight across again, we get the square root of 3. These two square roots of 3's, it's kind of like we're taking the square root of 3 and squaring it. That is why we end up with 3, and that's how we get rid of the square root in the denominator. This would be your answer. So you would do this for 2, 3, 5, and 6. Remembering that your sine value is your y and your cosine is your x. Also remembering that tangent is y over x. So then we go on to our table. Our table is asking us to identify the amplitude, period, phase shift, and vertical shift. So for these, we have to remember what each one means. So if we were given y equals a times sine or cosine, bx plus c plus d. So according to this, our a is our amplitude, our b is going to be our period, or what's going to be used to find our period. C is going to be our shift. It's going to be that shift up or down, or left to right, my bad. And then our D is going to be our vertical shift. That's going to be our up and down. So if you would like, you can put your A, B, C, and D on top. So looking at our first problem, we can rewrite this so we can see each letter correctly. We have y equals negative sine of 1/3 times x, because that can be written either way and it'd be the same value, plus 5. So our a is going to be a -1. So the first one for your amplitude is -1. Your b value is here at 1/3. So if we were only asking for b, it'd be 1/3, but we're asking for your period. Your period is 2 pi over b. So we're going to take our 2 pi, we're going to divide by 1 over 3. We've got two switches, so we have 2 pi times 3 over 1, which is simply 6 pi. Then we have our phase shift. Remembering that our phase shift, or our c, was inside the parentheses with our b and our x. So for number 7, there is nothing off to the side or inside the parentheses for our c. So there's not going to be a phase shift for this one. So you can put none, you can put no, or you can put 0. And then your vertical shift is going to be that D. Vertical shift is going to be on the outside. So that plus 5 is going to give you that vertical shift. So you need to say either up or down. This one's positive, so it's up 5. You're going to do the same for the rest. We're going to skip to 10. So number 10 we can rewrite so we can clearly see which letters are which. So we have y equals -4 cosine of x minus pi plus 3. So your a is going to be your amplitude, which is -4. Your b is that coefficient of x, which is I understood 1. So remember, don't do what I just did. 1 is your b. B is not just your period. So you have to take your b and substitute it in for b for the equation for period. So 2 times pi over 1. The same thing as 2 pi. Then you're looking for your c. Well, don't have to go far to find your c. Your c is whatever was adding or subtracting to your x. So your phase shift is going to be -pi. And that's going to be going to the right. A way to remember this is that your -pi was inside. So if we're inside, we're scrunched up, we're mad at our parents, we're going to be disobedient to the sign. So it's negative, so we're going right. And then lastly, we have our plus 3. So our plus 3 is on the outside, so it's going to tell us up 3. Alright. So 11, 12, and 13, we had to create our equations. So our amplitude is already given. So our first part is going to be equal to 3. Then our sign is what was specified in the direction. So we have sine. Then we have parentheses, Then we have to figure out what our b is. Our period is how long it takes for our graph to start repeating its pattern. Our b, however, is what's actually in our equation. So we're going to take our 2 pi and we're going to set it equal to 2 pi over 1, or over b. And we have to find our b, so we can switch it. So we have b equals 2 pi over 2 pi. And what I'm switching is the 2 pi out front and the b. This is solving it for b, and you simplify and you get 1. So I have just x. I do not have a phase shift in this one, or a c, so I just have x in the parentheses. Then I have a vertical shift of positive 1, so I have plus 1. And there is my equation. Let's do 13. 13, we are given the amplitude. So the first number after the equal sign is going to be 1/2. Sine was specified, so this one is also sine. Your period, we're going to take that period and set it equal to 2 pi over b. A trick to solve for b is to switch the pi over 2 and the b. So we get b equals 2 pi over pi divided by 2. We're going to keep change. So we get 2 pi times 2 over pi, multiplying straight across. Sorry guys, I made a mistake. I put pi over 2 instead of pi over 3. So let's go back and fix it. There we go. So multiplying straight across, you have 6 pi over pi. Pi divided by pi ends up being 1, so those cancel out, and you're left with 6. So that means your b is 6. That means in your parentheses, as your coefficient of x, you have 6. And then your vertical shift is outside, so you have subtract 5. And this is your equation. So 14, you're given an equation, and you're asked to multiply the amplitude by 3 and the period by 4. So the first thing you have to do is find your amplitude and your period of the original one, so you can multiply it. So your amplitude of the original is 4. So I'm just going to put OG. We want our amplitude and our period. The original is 4. The period is 1. So your period we do not know, but we can find out because our b for original is 1 over 3. So we have 2 pi over 1/3. Keep change. So we keep the 2 pi. We change the division to multiplication, and we flip or change the second fraction. So we have 6 pi is our original period. So our new period and amplitude, 4 times 3 gives me 12. And our new period is taking our old, which it was 6 pi, timesing it by 4, and we get 24 pi. Now, new equation. We can simply put in our new amplitude. It said nothing about changing the trig function, so we still have cosine. And now we have to figure out our new b. So we're taking 2 pi, or 24 pi, my bad. And setting it equal to 2 pi over b and solving for b. We will get 2 pi over 24 pi equals b. Pi's cancel out. You simplify 2 over 12, or 2 over 24, which is 1/12. So that is our new b. So it also did not say anything about changing the vertical or horizontal shifts or your phase shifts. So the -2 and the +1 stays the same. So there is your new equation. So on the next page, we have number 15. It asks for our key features of an amplitude, vertical shift, period, domain, and range. So your amplitude is half the distance from your min and your max. So if you come in here, your max point is at 2, your min point is at -4. So an easy way to look at this is from -4 to 0, you have 4, and from 2 to 0, you have 2. So 4 plus 2 gives you 6, and then half of that is going to give you 3. So I did 4 plus 2 gave me 6, and I'm dividing by 2 to get 3. Now vertical shift. Vertical shift is referring to our parent functions, which we did Friday/Monday. All of them were about the x-axis. So all of them started off as being on the x-axis. Well, now it's not. If we cut our graph in half horizontally, it would be at -1. So how did it shift from our x-axis to -1? It went down 1. So you would put down 1. And then your period, you are having to cut. It does not matter where it is. You're having to cut where the pattern starts and where it ends. So we can say it starts at the y-axis, and the next time that's in the same spot or finishes the pattern is over here at the end of our graph. So how long did it take for it to finish its pattern? 1, 2, 3, 4, 5, 6. Now I would accept 12 as the answer, but do you realize our y-axis was counting by 0.5? So we can assume that our x-axis was counting up by 0.5. So your period is 6. Your domain, well, it goes all the way to the left forever and all the way to the right forever. So it's -infinity to +infinity. And then your range is your y values. So the smallest y value is -4. And your biggest is at 2. So -4 to 2. So I'm going to keep going. So number 18. Number 18 tells us that graph one period of each in the area provided. Tomorrow you will be given graph paper, but we can sketch these. So we first need to identify what our area or amplitude is. We have A equals our understood 1 there. Now our period we can find because our B is 1. So we have 2 pi over our B, which simplifies to 2 pi. Now to find the start of our table, and yes, you need a table, we are taking our bx plus c and setting it equal to 0. This is that bx plus c is what's in the parentheses or right behind the sine or cosine. So this one we only have one x and we have no c, so we can just put plus 0 equals 0. And then you're solving for x, so you get x equals 0. To find your stop, you're taking your start and you're adding your period to it. So we have 0 plus 2 pi, which is the same thing as 2 pi. So how do we create a table from this? Well, we take our start, which is 0. We take our stop, which is 2 pi. And then we find the middle in between 0 and 2 pi. Hopefully, you can say that in between 0 and 2 pi is pi. And in between 0 and pi is pi half. And then we have in between pi and 3 pi and pi and 2 pi, we have 3 pi over 2. You can also find this on the unit circle. If we only want to go half of the circle, because the whole circle is 2 pi, if we only want to go half, it is at pi. And then if we want to cut the semicircle in another half, the top is pi over 2. Same thing for the bottom. If we're only looking up from pi to 2 pi, the bottom semicircle, and you cut that semicircle in half, you would end up at 3 pi over 2, where that 270 degrees is. And then you are substituting these x values into the original equation in your calculator. Once you do this and making sure that you are in radians and not degree mode, your y value should be 0, negative 0.7, 0, and I skipped one, 0.7, and 0. Now if you wanted to sketch this, you're starting at 0. You've got your x-axis, you've got your pi over 2, your pi, your 3 pi over 2, and your 2 pi. So we need to label these. And 2 pi. So we have our positive 0.7 and our negative 0.7. So we got 0, 0. We've got one down here. Back at 0, y is 0. 3 pi over 2 is positive. And back to 0. So here is our graph. Again, key thing is to make sure that you are creating your start and your stop and filling in your table. So let's do one where it's not the typical x values. So we've got to create our start and our stop. We first start with creating our amplitude, which is -2, or simply 2. Your period can be found by taking your b, 2 pi over 2. You're simplifying this to simply pi. And then your start is your 2x plus pi over 2 equals 0. You move that pi over 2 by subtracting. You get negative pi over 2. Got to divide by 2 again. X equals, well, you can keep change, so negative pi over 2 times 1 over 2. Same thing as negative pi over 4. So your x, or your start value, is negative pi over 4. And then your stop is taking your start, which was negative pi over 4, and adding your period, which was pi. You can put this into your calculator, and you get 3 pi over 4. So your table will look like this. You have negative pi over 4, and your stop at the bottom is 3 pi over 4. In between these two angles, you have pi over 4. And then between negative pi over 4, you have 0. And in between positive pi over 4 and 3 pi over 4, you have pi over 2. And then you're substituting these x values into your calculator, into the equation that's given. So you will get negative 4, negative 2, 0, negative 2, and negative 4. So your graph should look like this. You have to have your negative pi over 4. You have a 0, then you have pi over 4, pi over 2, and 3 pi over 4. So here are your x values. You don't have to put a 0 if you don't want to. Again, if you did not hear me today, I am not focused on you making these graphs perfect. I'm more worried about your table being perfect. So we have 1, 2, 3, 4. Here's our first dot, second dot, third dot, fourth dot, fifth dot. And there we are. There's our sketch of our graph. So then we go on to our word problems. So we have, suppose that the function f of t equals 9.5 times the sine of 0.021 t minus 1.25 plus 13. That models the hours of sunlight for a town in Alaska, where t equals 1 is the first day of the year. Based on the function, what is the approximate range of daylight hours for the town? So we see that our amplitude, or A, is positive 9.5. So our vertical shift is going to be plus 13. So So when we graph it, instead of it being around our axis, it's going to be up some. So it's going to be that middle line that we were talking about. So if our middle line is at 13 and our amplitude is making our max 9.5 above our midline and making our min 9.5 below, we can find these min and maxes. So our max is going to be 13 plus our 9.5, which gives us 22.5. And our min, or our minimum of hours, is at 13 minus 9.5, which will give us 3 hours and 3 hours and 30 minutes. So our range is from 3.5 to 22.5. And then lastly, we have 23. As you ride the Ferris wheel, your distance from the ground varies simultaneously with time. You are the last seat filled on the Ferris wheel. It starts immediately. Let T be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 4 seconds to reach the top, 40 feet above the ground, and that the wheel makes a revolution once every 9 seconds. The diameter of the wheel is 37 feet. So best thing is to draw a graph or draw a picture. So here's our Ferris wheel. The diameter is 37. So our top of our Ferris wheel, so everything is 40 feet. So that means the space underneath the Ferris wheel to the ground is 3 feet. That also means the radius is 18.5. The reason why it's 18.5 is 37 divided by 2. So if we wanted to sketch a graph, we're only needing our positive or our quadrant 1, because we're not going to go negative time, or we're not going to go negative feet in this problem. Our lowest point on the Ferris wheel is at 3 feet. Our tallest point of our Ferris wheel is at 40 feet. And it's going to take 9 seconds to complete a whole rotation. So starting at 0 seconds and at 3 feet, we're going to go all the way up, and then we're going to come all the way back down. So this would be our sketch. And what is the lowest you go as the Ferris wheel turns? Well, our lowest point, right here on our drawing, is at 3 feet. And then it asks, and why is it this number greater than 0? And in so many words, I put on my answer key, because the diameter is only 37 feet, not 40 feet. So we had a space in between our whole circle and where we were told the top of the Ferris wheel to the ground was. Another thing that I pointed out on my answer key was it is not sitting directly on the ground. So it kind of makes sense. If you've never seen a Ferris wheel, it doesn't rotate hitting the ground every single time it goes around. There is some kind of contraption that I kind of drew on my picture holding it up in the air so it won't drag. So now we have to write our equation. RA, or our amplitude, is always our radius. So our radius for this one is 18.5. Our period is going to be found by taking our 9 seconds and having our 2 pi over b equals our 9 seconds. We're going to find our b by doing 2 pi over 9. Simplifying this, we will keep it as 2 pi over 9. So we have y equals cosine equals our a, which is 18.5, times cosine. Our b is 2 pi over 9 times our x. And then we have a vertical shift of 21.5. Our 21.5 is coming from adding our amplitude, or our radius, and that space underneath our Ferris wheel. So from the middle of the circle down is 21.5. So if you need to, write it off to the side. Your vertical shift is your height of the center of circle. So the height of the center of the circle for this one is that positive 21.5. And that is our equation for number 23. And then the last part is us simply substituting those values into our equation. So when you do this, you should get 38.88. For number 2, you should get 3. And for 3, you should get 18.29. So remember, as you look through these answers, if you have any other questions, please don't hesitate to email me. I will try to answer all of your questions.